Naming type 1 binary ionic compounds. Binary compounds are composed of two types of elements, such as H2O or KBr, not necessarily just two atoms. For example, H2O, which we know is water, is composed of three atoms, two atoms of hydrogen and one of oxygen. Potassium bromide is composed of two atoms. Diatomic molecules consist of two atoms of the same type, such as hydrogen or oxygen. These two molecules exist only in pairs. So there are two types of binary compounds. They're either ionic compounds, which means it's a metal bonded with a nonmetal through an ionic bond, such as NaCl or CaCl2, or binary covalent compounds, which means they are a nonmetal and a nonmetal bonded together with a covalent bond, such as water or carbon dioxide. Binary ionic compounds contain a positive cation and negative anions. Remember, positive ions come from the left side of the periodic table and negative ions come from the right side. Type 1 compounds, which is what we're going to practice naming in this presentation, in these, the metal that's present forms only one cation, so there's only one possible oxidation number. Type 2 compounds, which we will practice naming later, these deal with the transition metals from this section of the periodic table, and that metal can form two or more cations with different charges, so they have different oxidation numbers. The rules for naming type 1 ionic compounds are pretty simple. The cation, which is the metal from the left side of the periodic table, is always named first, and the anion, or the nonmetal, is always named second. A simple cation takes its name from the name of the element, so you just name the element that you see first. And then the anion is named by taking the first part of the element name, or the root of it, and then adding IDE, or IDE. For example, we have KCl. K is the symbol for potassium, and Cl is the symbol for chloride, so the name of this compound is potassium chloride. MgBr2, this is magnesium bromide. Magnesium would be the metal, and bromine would be the nonmetal. And then CaO is calcium oxide, calcium being the negatively charged metal ion, and oxygen being the positively charged nonmetal ion. So you can see you just name the first element and then add "ide" to the second element. Metals are in groups 1, 2, and 3 on the periodic table, and then nonmetals. When we name these, we name the metal first, and then we add the name of the nonmetal plus the "ide" ending. So if we start with sodium and bond that to chlorine, we get sodium chloride. If we start with calcium and bond that to bromine, we get calcium bromide. Or if we start with aluminum and bond that to oxygen, we get aluminum oxide. So let's take a look at this question. What's the name of this compound? SrBr2. If you are looking up these elements in your periodic table, you will notice that Sr stands for strontium, Br is bromine, and since this is a type 1 ionic compound, we have a metal from groups 1, 2, or 3, and a nonmetal, then we can simply name this strontium bromide. Here are some examples of possible cations and anions that you might be using in this practice assignment coming up. So we have hydrogen, lithium, sodium, potassium, cesium, beryllium, magnesium, calcium, barium, aluminum, silver, and zinc. You might notice that zinc, silver, and another one, cadmium, these fall into the transition metal area, but they always have the same oxidation number. Even though they're found in the transition metal area of the periodic table, they follow the rules for a type 1 binary ionic compound. So remember that. Silver, zinc, and cadmium follow the rules for type 1. Some possible anions that these could be bonded with include hydrogen, fluorine, chlorine, bromine, iodine, oxygen, or sulfur. These become hydride, fluoride, chloride, bromide, iodide, oxide, and sulfide when you add the IDE ending. Feel free to use this table to help you name binary ionic compounds in the practice assignment that you will do this week.